everyone, I am Deep Patel from the Department of Mechanical Engineering. Today we are going to start our new chapter, that is chapter number 8, pump. We all know that pump is the device which is used in our daily life. Okay, when we want to transfer the liquid from one place to the another place, we are generally using the pump. So we can say that pump is the device which is used to convey the liquid from the lower elevation to the higher elevation. Okay, so today we will discuss about the pump. What is the meaning of pump? What is the different kinds of heads in the pump? Then we will discuss about first basic pump, that is the reciprocating single acting pump. Okay, then we will discuss about the problems of the reciprocating pump, and then we will discuss about the air chamber. Okay, so let us start with the definition of the pump. So, first of all, we can say that the pump is the device which conveys the liquid from one place to the another place. Okay, we know that pump is used to increase the pressure energy of any liquid. Okay, so to increase the pressure energy of liquid, we are generally using the pump. Okay, second, we can say that it is the hydraulic machine which converts the mechanical energy into the hydraulic energy. Okay, so we know that in pump there is one motor is fitted. So when we rotate that motor, with the rotation of motor the impeller is rotated, and due to the rotation of impeller the vacuum is created, and after that the liquid will gain some pressure energy. Okay, so we can say that ultimately what happens, the mechanical energy is converted into the pressure energy, and then with the help of that pressure energy liquid is conveyed from the lower elevation to the higher elevation, and ultimately at the higher elevation it will gain some hydraulic energy, okay, or the potential energy. So we can say that pump is the hydraulic machine which convert the mechanical energy into hydraulic energy. Okay, so let us discuss about the some terminologies which are using in the pump. Okay, so the first terminology is the head. Now what is the meaning of head? So we can say that in the pump the different form of energies are expressed in terms of the height, and that is known as the head. Okay, so if we talk about the pressure energy at some elevation, so that pressure energy we will indicate it by the head. Means if the height is 2 meter, then we can convert it into the pressure energy according to the equation P equals to rho gh. Rho is the density of the liquid, g is the gravitational acceleration, and h is the height which is gained by the liquid. So with the help of that height we can gain the value of pressure energy. Okay, so in the pump we will describe height as the energy. Okay, so this is the simple meaning of head. Now there are two sides in the pump. One is the suction side from which the water will be gained into the pump, and second is the delivery side where our delivery tank will be fitted. Okay, so according to the suction height and delivery height, we are dividing the head into the suction head and the delivery head. So our first term is the suction head. So in the suction head what happens? Suction head is the height between the suction tank to the center of pump line. Okay, so we can say that the suction height or the suction head is the vertical height of the center line of the pump shaft above the surface of liquid from which it will be conveyed, or it is the energy which is required to lift the liquid from the sump to the pump. Sump means the bottom tank from which we are going to convey the liquid. Okay, so this is the simple meaning of the suction head, okay, or the suction energy or the suction height. Okay, second is the delivery head. Now what is the meaning of delivery head? Delivery head means the height at which we have to deliver the water from the center line of the pump. Okay, so the delivery head means it is the vertical height between the center axis of the shaft to the delivery or the discharge tank. Okay, so we can say that here the third point is the delivery head. Here you have to understand the delivery head. Delivery head means it is the vertical height of the center line of the pump shaft to where the liquid is delivered. or we can say that it is the energy required to lift the liquid from the pump axis to the delivery pipe or to the discharge tank. Okay, so this is the simple difference between the suction head and the delivery head. Suction head means the liquid to the or the bottom tank to the center line of the pump, and the delivery head means the height of the center line of the pump to the discharge tank. Okay. Next, we will discuss about the velocity head. So, what is the meaning of velocity head? Velocity head is the kinetic energy which is carried by the liquid at the end of delivery pipe. So, this is the simple meaning of the velocity head. Okay, and the formula of the velocity head is the v square by 2g. Now, second is the static head. So, we can say that the total head which is required to convey the liquid from the suction side to the delivery tank, that total head is known as the static head, or we can say that static head is the sum of the suction head and the delivery head. Okay. Next is the manometric head. Now, what is the meaning of this manometric head? Manometric head means that it is the total head required to be developed by the pump. So, in the manometric head, we will consider all the losses, like we will consider suction head plus delivery head plus velocity head. This is the three basic head, or this is the three basic energy. Also, we will add some energies of losses like friction loss in the suction pipe, friction loss in the delivery pipe, friction loss in the pump casing. This all losses will be considered in the side the manometric head. Okay, so there is a difference between the static head and the manometric head. Static head means it is the total height or the total energy from the suction side to the delivery side, that is the HS plus HD, suction head plus delivery head. But in the manometric head, we will consider all types of head like velocity head, like the losses in the suction pipe, losses in the delivery pipe, or we will consider into it. Okay. Now, next term is the water power. Now, what is the meaning of water power? So, we can say that it is the power required by the pump to handle the liquid to develop the manometric head. Okay, so to move the water from the suction side to the delivery side, the total amount of the energy which is required, that is known as the water power. Okay, now second is the shaft power. So what is the shaft power? So we can say that it is the power input to the shaft of the pump by the motor. So how much amount of the power we have to deliver the motor to run the pump, that is known as the simple shaft power. Okay. And finally, the efficiency of the pump. So we can say that the efficiency of pump is the ratio of the water power to the shaft power. Okay, so this is what all about the terminologies of the pump. Okay, so in the terminologies we have discussed about the different heads like suction head, delivery head, velocity head, static head, manometric head. Okay, then we will discuss about the water power and the shaft power and what is the meaning of efficiency of the pump. Okay, so with the help of this terminology, we will understand different types of the pump. Okay, so let us start with our first type of the pump, that is the single acting reciprocating pump. Okay, so this is the single acting reciprocating pump. So before going to understand the working of this pump, let us understand some basic components of the reciprocating pump. Okay, so here you can see the diagram. In the diagram, you can easily understand that there is one crank which will rotate from 0 to 360. Okay, 0 to 90, 90 to 180, 180 to 370. Okay, so this will rotate. This is known as crank. Now second is the connecting rod. Okay, so the connecting rod is directly connects to the crank and it will connect with the piston rod. So simple we can say that the connecting rod is used to move or to transfer the reciprocating motion of the piston rod into the rotary motion of the crank. Again I am repeating. What is the meaning of or what is the application of the connecting rod? Connecting rod is used to convert the reciprocating motion of the piston rod into the rotary motion of the crank. So here you can see that there is a connecting rod. One end of the connecting rod is connects with the piston rod and another end of the connecting rod is connects with the crank. Okay. Now third component. Third component is the piston rod which is directly attached with the piston. Okay. So here you can see that is the blue color, the rectangular box is the piston. Okay. Now there are two types of the valve. One is the suction valve and second is the delivery valve, which is indicated by the red color you can see in the diagram. Okay, so what happens here? The suction valve is fitted into the suction pipe and second is the delivery valve. Delivery valve is fitted into the delivery pipe. Now what happens here? During the suction time, this suction valve will be open and the delivery valve will be closed. Now during the delivery of the water, the delivery valve will be open and suction valve will be closed. Okay, so according to the pressure difference, this suction valve and the delivery valve will open and close. Okay, now there is one suction pipe. So we can say that suction pipe is the pipe which is convey the liquid from the sump, that is the bottom level of the liquid, that is the sump, to the piston. Okay, so we can say that the suction pipe is the intermediate pipe which convey the liquid from the sump level or from the bottom dead to the pump. Okay, after that there is one delivery pipe. Delivery pipe is used to convey the liquid from the pump to the discharge tank. Okay, there is one discharge tank. Okay, so we can understand that there are main components of the pump is crank, connecting rod, piston rod, suction valve, delivery valve, suction pipe, delivery pipe. There is one bottom tank that is known as sump and there is one upper tank that is known as the discharge or the delivery tank. Okay. So this is what all about the components of the reciprocating pump. Now we are going to discuss about the working of the reciprocating pump. Okay, so let us start the working. What happens here? Here you can see the piston will be travel from the inner dead center to the outer dead center. Now what is this meaning of inner dead center? Okay, inner dead center means it is the leftmost position of the piston inside the cylinder. Okay, and outer dead center means it is the outermost position or the rightmost position of the piston in the cylinder. Okay, so when the piston is near to the valve, okay, that is our inner dead center. Okay, now what happens? At the initial condition, the crank will be at 0 degree. Okay, and piston is in the leftmost position. So what happens? The pressure inside the pump will equals to the atmospheric pressure. Now what happens? When the crank will be rotated from 0 to 90, the connecting rod will be moved to the rightward direction. Also with the connecting rod, the piston rod and the piston will be moved from left to right. Okay, now when piston is moves from the left to right, there is a vacuum is created inside the pump. Okay, vacuum means the pressure below the atmospheric pressure. So the vacuum is created inside the pump. Now due to this vacuum or due to this pressure difference, what happens? The tank having the pressure, that is the atmospheric pressure, and the vacuum is created inside the pump. So what happens? The pressure difference is created between the sump level or from the bottom tank and the inside the pump. There is the pressure difference. So what happens? The liquid will be conveyed from the bottom tank to the pump due to this pressure difference or due to this vacuum. Okay, so when this crank will reach at the 180 degree, that is our forward stroke. So when the crank is reached from 0 to 180, the piston will move from the leftmost position to the rightmost position or from the inner dead center to the outer dead center. Simultaneously what happens? The liquid will move from the bottom tank to the pump. Okay, after that the suction valve will be closed and the delivery valve will be open. Okay, now what happens? Here you have to understand that piston is at the rightmost position, the liquid will be kept inside the pump and crank is at 180 degree. This is what all about our forward stroke. Now what happens? Piston will move from the rightmost position to the leftmost position, or we can say that the piston will move from the outer dead center to the inner dead center. So what happens? The crank will move from 180 to again 360 or 0 degree. The piston will move from the outer dead center to the inner dead center, and the liquid which is already available in the pump will be pushed by the piston, and so that the liquid will be goes to the delivery pipe. Why it is goes to the delivery pipe, not in the suction pipe? Because here the suction valve is closed and the delivery valve is open. So what happens when the piston is moves from the outer dead center to the inner dead center, or from the right to left, the liquid will be pushed by the piston, and finally from the delivery valve it will reach to the delivery pipe, and ultimately it will reach to the discharge tank. Okay, so this is how liquid will be delivered during the return stroke or during the delivery stroke. Okay, so we can say that in the single acting reciprocating pump there are two types of stroke. One is the forward stroke and second is the reverse stroke or the return stroke or the delivery stroke. Now in the forward stroke or the suction stroke, what happens? The crank will move from 0 to 180, piston will move from left to right, and the liquid will move from the bottom tank to the pump. After that, what happens? During the reverse stroke or during the return stroke, the crank will rotate from 180 to 0. Then piston will move from right to left, and the liquid which is already available in the pump will be pushed by the piston. So the liquid will be goes to the delivery pipe via delivery valve, and ultimately it will reach to the discharge tank. So this is what all about the working of single acting reciprocating pump. Okay, so here all the description is given. Now during the forward stroke, what happens? The crank will rotate from 0 to 180 and piston will move towards the right side. Next, this create the vacuum in the cylinder on the left side of the piston and causing the suction valve to open. Now when the suction valve will open, the liquid or the water will be enters into the cylinder. Now second is the reverse stroke or the return stroke. In the return stroke, the crank will rotate from 180 to 360 and then piston will move from the right to left, and this cause the increase of pressure inside the cylinder, and due to that the liquid will transfer to the delivery tank. Okay, so this is what all about the forward and return stroke. Now there are some problems which is associated with the single acting reciprocating pump. Here you can understand that the problem with the single acting reciprocating pump is that here flow is not continuous, it is the pulsating. Why pulsating? Here what happens during the suction stroke or during the rotation of crank from 0 to 180, only the liquid is shock inside the pump. Okay, it will not deliver to the discharge tank during the suction stroke, and again during the return stroke the liquid will be delivered. Okay, so we can say that here the flow is not continuous. When crank will rotate from 0 to 180, the liquid will not come to the delivery side, and when the crank will move from 180 to 360 or 180 to 0, the liquid will be delivered. So at some time liquid will not deliver and at some time the liquid will deliver. Okay, so we can say that here the flow is not continuous, it is the pulsating, and due to this pulsating nature the energy is losses. Okay, so to reduce this energy loss we can use the continuous flow. Okay, so how we can maintain the continuous flow, that we have to discuss in this lecture. Okay, so this is the first problem associated with the single acting reciprocating pump. Okay, so our basic need is to maintain the continuous flow. Okay, so to maintain the continuous flow, what we are going to do? We are going to use the air chamber. So let us discuss about the reciprocating pump with the air chamber. Okay. So this is the diagram of the single acting reciprocating pump with the air chamber or air vessels. Okay. So here you can see all the components are as it is. That is the crank, connecting rod, piston, suction valve, delivery valve, suction pipe, delivery pipe, suction tank and the delivery tank, all that are same. Okay, but here we are going to use two different air vessels or the air chamber. One air vessel is fitted into the suction side and second air vessel is fitted into the delivery side. Now, what is the benefit we can get from the air vessels? Okay, so what happens in the air vessels? Already some air is filled. Okay, in the suction air vessel and the delivery air vessel, already some air will be filled. Now, what happens when the piston is moves from 0 to 180? The vacuum is created, and due to the vacuum the liquid will move from the suction side or from the bottom tank to the pump. So during the movement of the liquid from the bottom tank to the pump, some amount of the water will be trapped inside the air chamber. Okay, and when the water is trapped inside the air chamber, the air which is already available in the air vessel will be compressed. Okay, this is the same thing is happens during the delivery stroke. During the delivery stroke, what happens? The piston will be moves the water, okay, or piston will be push the water to move into the delivery pipe, and during which what happens when the water is delivered during the delivery stroke, some amount of the water will be trapped inside the air vessel at the delivery side. So the air which is already available in the air vessel will be compressed by that liquid. Okay, so this is the basic initial condition you have to understand. Now what we can get from this air vessel? What happens when there is a forward stroke? The piston will move from the left side to the right side. So during which what happens? The liquid will be conveyed inside the pump. Okay, and during the delivery stroke, the piston will move from right to left, and during this the liquid will be delivered by the delivery side. Okay, so here the nature is pulsating. Now what is the benefit we can get from this air vessel? What happens when the piston is moved from the left to right during the suction stroke? The liquid which is trapped inside the air vessel will be delivered into the delivery pipe, and then it will enter into the discharge tank. Okay, so we can say that here during the suction time we can get the water inside the delivery pipe. Okay, so the problem was the reciprocating problem was that during the suction time no water was available, but with the air of the or with the help of the air vessel we can get the benefit that here what happens when the piston is moved from left to right, we can get the water from the air vessel to the delivery pipe. So we can say that at the discharge tank we can get the continuous flow. Also you can here imagine what happens during the suction stroke there is a water in the suction pipe, but during the discharge stroke there was no water in the suction pipe. So same function is doing by this air vessel at the suction pipe. Okay, what happens during the discharge stroke? The suction valve will be closed, but the water will be delivered by the air vessel to the suction pipe. Okay, so the suction pipe will be filled by the water. Also, the delivery pipe will be filled by the water with the help of the air vessel. So we can get the continuous flow with the help of the air vessels. Okay. Also, there are some other function of the air vessel. First function is that it will provide the continuous flow. Okay. Second benefit that we can get from the air vessel, that the friction losses or the losses which occurs in the pump, there will be minimum with the help of this air vessel. Also, the problem of the cavitation can be reduced by the air vessels. Okay, so these are some main objectives or the main functions of the air vessel. So air vessel is the very important component in the single acting reciprocating pump. Okay, so let us describe it. The main objectives or the air chamber or the air vessels are the to obtain the continuous supply of the liquid. This is our first and the main objective. Okay. Second, to pump the or to run the pump at the high speed without the cavitation. And third is the to save the considerable amount of the work or to reduce the losses. So we can save the considerable amount of the work in overcoming the frictional resistance or to reduce the frictional losses. Okay. So we can say that the top of the air chamber contains the compressed air which can contract or the expand. Now during the delivery stroke, the suction valve get closed and the flow from the suction pipe is taken into the air chamber fitted at the suction pipe where it is temporarily stored. Okay, and finally what happens? It will deliver some water to the suction pipe, so we can get the continuous flow. Okay, so similarly, during the suction stroke, the delivery valve is closed, but the delivery of the liquid from the discharge tank is continuously supplied by the liquid which is available into the air chamber which is fitted at the discharge pipe. Okay, so you can say that thus the air vessel works as the intermediate reservoir. Intermediate reservoir means it will supply the liquid. So we can say that it is the intermediate reservoir that maintains the continuous discharge of the liquid into the suction pipe and into the delivery pipe. So this is the main function of the air chamber. Okay, so this is what all about the air chamber. So in this lecture we have discussed about the basic terminologies of the pump. Then we have discussed about the single acting reciprocating pump and what is the problem associated with the single acting reciprocating pump. Then we have discussed about the air chamber. Okay, so this is what all about today's lecture. Thank you for today.